Hello and welcome back to Math with Mrs. Becker. Today in pre-calculus, we are going to go ahead and start section 3.5, where we get to work with functions and operations of functions. There are several ways in which two or more given functions can be used to create a new function. In this section, we will be finding the sum. Remember, the sum means that you are adding. We will find the difference between two functions. Difference means that you'll subtract. Product, we will multiply. Quotient, we will divide. And that's as far as we will get today. Then on Thursday, sorry, I almost said Wednesday. Then on Thursday, we'll do what's called composite functions. Okay, so we'll look at 5 different things. Finding the sum, the difference, the product, the quotient today. Then on Thursday, we'll look at compositions or composites of functions. We will continue to learn more about the domain of a function by finding the domain of each new function that we created, okay? Remember domain, we have 2 limitations. You cannot divide by 0, and you cannot have a negative number underneath the square root, okay? So if I'm looking here, whenever they want us to use the f function, we will use negative 3x plus 2. G is x squared, h is 1 over x, m is x squared plus 2x minus 5. Here, they want me to take the f function and add it to the g function and leave it in terms of x. So the f function is negative 3x plus 2. Add it to the g function, which is x squared. Now here, when you're adding, what you actually do is you just combine like terms. And that might be a nice little note to make right within your notes. If they want you to add, all you're doing is combining like terms. If I look right here, there are no like terms. This has 2 x's, this has 1, this doesn't have any. So when I go ahead to find my final answer, you want to put it in that standard form that we talked about previously in this class, where you go from the most amount of the variable to the least. So 2 x's, 1 x, no x's. Here is your new function. Now that's really cool. We took these 2 functions, and by adding them together, we created a whole new function. Your domain, in this case, is all real numbers. Because, do I have a fraction? No, so I don't have to worry about dividing by a 0. Do I have square roots? No, so I don't have to worry about a negative underneath. So that means x can be any value. This is that symbol for all reals. Okay. Next one, take the f of x function, negative 3x plus 2, minus the g of x function, x squared. So again, the main thing here is you just have to realize that that negative applies to whatever's behind it. So I have negative 3x plus 2 minus x squared. Again, at this point, you combine like terms. Well, my friends, we don't have any like terms. This has 1x, this has no x's, this has 2. So when I put it in the right order, negative x squared would go first, then a negative 3x plus 2. Here is the new function that you can create if you take the f and g function and simply subtract them. Again, your domain, and this time I'll use the words instead of the symbol, it's all reals, because I don't have any of the limitations. I don't have a fraction, so I don't have to worry about dividing by 0. And I don't have a radical, so I don't have to worry about negatives underneath the radical. Okay, next one. Now this time, notice that they have a number here. And I'm going to show you what that number means as soon as we find the new function. So I take the m function and I add it to the f function. So m, x squared plus 2x minus 5, add it to f. Negative 3x plus 2. So here's the m function, here's the f function. They want you to add them together. Adding is combining like terms. So I go ahead and combine like terms. I only have one term that has a power of 2, so x squared comes first. Positive 2x minus 3x. 2x minus 3x is negative x. Negative 5 plus 2 is negative 3. So here's your new function. Now, if they have a number here, this means once you have calculated the new function, what is m plus f, now you replace all of the x's with a 2. So it's 2 squared minus 2 minus 3, and we will not only have a function solution, we will also have a numerical solution. So first you find m plus f, then you replace the variables with a 2. 2 squared is 4 minus 2 minus 3. 4 minus 2 is 2. 2 minus 3 is negative 1. Your domain, again, no fractions, no radicals, so your domain is all reals. Okay, the next one, h of x plus g of x. And notice in the notation that the x stayed the same, so we don't have to replace it with a number, we just leave it as x. H of x is 1 over x, plus g of x is x squared. Now here's the deal with this. We are adding fractions, okay? You cannot add a fraction unless you have a common denominator. X squared is not a fraction the way that it's written, so I go ahead and I put a 1 underneath. I cannot add these together unless this has a value of x. So I need to multiply both top and bottom by x. So the first fraction stays 1 over x plus 1 times x is x. The top, x squared times x is x cubed. Now, when you add fractions, the common denominator stays. So the bottom is just an x. On the top, I cannot combine these. This is a number. This is a variable with an exponent of 3. So what I have to do is put both pieces on the top in standard form. So x cubed plus 1, there is your new function. Okay, so again, if you're adding like we are, you're adding, in this case it was fractions. Remember, you cannot add fractions without a common denominator. When you are adding fractions, once you obtain the common denominator, that carries on over. What you're really adding are the numerators. Well, our numerators in this example were not like terms, so I did have to have both pieces on the top. Now your domain this time, you cannot divide by 0, so x could never be a 0. This means x can be any other value, but if you put a 0, you cannot have a 0 on the bottom of a fraction. Okay, let's look at the next one. Take g x squared minus h 1 over x. Then, once we've done that, they want us to go ahead and replace the x's with a 3. So again, just like last time, I'm subtracting fractions, so I need to realize this is really like x squared over 1. I need a common denominator. X times x squared is x cubed. X times 1 is x minus 1 over x. So I carry the common denominator over. I cannot combine these because these are variables and this is a number. So this is x cubed minus 1. My domain, x can never equal a 0 because you cannot divide by 0. Now, they had a 3 here. If they replace x with a number, that means once you have found the new function, you replace the x with that number. I have 3 cubed minus 1 over 3. Order of operations, I would do the exponent first. 3 cubed, 3 times 3 times 3 is 27. 27 minus 1 is 26 over 3. If I go ahead and I try to simplify 26 over 3, you cannot. I mean, you could always do the mixed number 8 2/3, but you could keep it as 26 over 3. I am totally good either way. Okay, last one like this. F minus m. So f is negative 3x plus 2 minus m. Now m this time has 3 terms, so this is super important. This negative, if you are minusing a function, you need to make sure that you minus every single term. So the negative needs to be distributed into every term of the m function. That gives me negative 3x plus 2. Negative times x squared is negative x squared. Negative times positive 2x is negative 2x. Negative times negative 5 is positive 5. Your new function, combine the like terms, put it in standard form. Negative x squared goes first. Negative 3x's, negative 2x's makes negative 5x's. Positive 2 and a positive 5 makes 7. My domain again is all reals because look at this. No fractions, no radicals. If there are no fractions, no radicals, your domain is all real numbers. Now, because they have a number in the place of x in the notation, I go here, and wherever there's an x, I put in a -1. Now, I just want to do this one on a calculator just to make sure that you realize how this would work. The negative out front, that would stay. What you're replacing is x. We are filling in a -1. So -1 would go in the parentheses in the place of x. Squared minus 5 in the place of x is a -1 plus 7. So my numerical solution is 11. Okay, let's look at the back side of the notes. Now what we're doing, okay, the whole front side, if you kind of look back at this, we were doing all just adding and subtracting, okay? So you have 6 examples for how to find the sum and difference. Now on the back, we are going to look at product and quotient. Remember, product means you're multiplying, quotient means that you're dividing. And again, we have 6 different examples, so hopefully you feel pretty confident by the end of the notes. This tells me that I need to multiply the f function by the g function, then just leave it in terms of x. So f is 4x squared plus x to the power of 4 times g. G is -4x plus 1. Notice this is 2 terms by 2 terms. If you are multiplying 2 terms by 2 terms, this is the good old-fashioned FOIL method. If I have 4x squared times -4x, remember you multiply the numbers and add up how many x's you have. +4 times -4 is -16. 2 x's and 1 x gives me 3 x's. Outside, 1 times 4x squared is 4x squared. Inside, x to the power of 4 times -4x is -4x to the power of 5. Last, x to the power of 4 times 1 is x to the power of 4. Now, if I notice, I can't combine any like terms here. This is kind of wild. This is 3x's, 2x's, 5x's, 4x's. None of these variables have the same amount, but this is not in the right order. You always want to have standard form, which means the most amount of the variable to the least. So in this case, my highest exponent is a 5, so that would come first, followed by x to the power of 4. Then -16x cubed plus 4x squared. Here is the new function that you created from these 2 functions by multiplying. They want us again to state the domain. My domain would be all reals because I don't have any fractions and I don't have any radicals. Okay, next one. If we are dividing h of x, 1 over x plus 2, over g of x, -4x plus 1. Well, here's the deal, guys. You cannot divide fractions. So what we need to realize is that -4x plus 1 is the same thing as -4x plus 1 over 1. The reason why I did this is because I created what's called a complex fraction. We already had a fraction on the top, so oftentimes it's easier to make both the top and bottom a fraction. Now it's our good old skip, flip, multiply thing, okay? So the top, the first fraction stays. We change divide to multiply. Then what we have to do is flip the other fraction upside down. So it becomes 1 over -4x plus 1. Now when you multiply fractions, top times top, 1. Bottom times bottom, and I am totally good if you do this. You could FOIL this if you wanted to, but you can stop right here. You can show that you know 1 times 1 is 1, and on the bottom you'd be multiplying those 2. The reason why I would allow you to stop here is because remember we have to state the domain. So when you're stating the domain, you have to realize that you could not make either of these pieces a 0. So if I go ahead and look at just that piece, what would make that piece a 0? -2. So x can never equal -2 because -2 plus 2 is 0. Now, what would make this a 0? And if you can't just look at it and tell, remember what you would do is take that piece and say, okay, that can't equal 0. So if I minus 1, -4x cannot be a -1. Divide both sides by -4. Negative divided by a negative is a positive 1/4. So x can also not be 1 over 4. So for that reason, I think that I would just go ahead and keep it like this. If you really want to FOIL it, go for it, but then you'd have to factor it to get your answers. Okay, next one. Take h times m, then replace it with a 4. But for right now, let's just go ahead and look. So h is 1 over x plus 2 times m. M is the square root of x. If you are multiplying fractions, remember it's top times top, bottom times bottom. So I'm going to go ahead and put a 1 underneath the square root of x, because then I can follow that common pattern that we're used to. 1 times the square root of x is the square root of x. 1 times x plus 2 is x plus 2. Here is your new function. Now, I have 2 limitations for the domain. The reason why, I have a square root and I have a denominator. So on the bottom, x can never equal negative 2, because negative 2 plus 2 is 0. But on the top, x must be greater than or equal to 0, because you cannot have a negative there. Okay, so your domain x must be greater than or equal to 0, otherwise that becomes imaginary. Now, go ahead and replace the x's with a 4. So square root of 4 plus 4 plus 2. Square root of 4 is 2. 4 plus 2 is 6. 2 over 6 can be reduced to 1/3. Okay, let's keep going. We have 3 more examples. H of x. I'm doing a lot with these fractions because typically this is where it's the most challenging. Okay, so h is on the top over m. Now again, because the top is a fraction, oftentimes it's easier to go ahead and make the bottom a fraction as well. Okay, so the top is a fraction, the bottom is a fraction. You cannot divide fractions, so we keep the top the same. 1 over x plus 2. Change divide to multiply. Flip the second one upside down. So it's 1 over the square root of x. Top times top is 1. Bottom times bottom. Again, I am totally fine if you keep it like this, because this is going to help us identify the domain. Now remember the domain, okay? You cannot have anything on the bottom equal 0. So x can never equal negative 2 because of this. Now, typically, whatever's underneath the radical symbol has to be greater than or equal to 0. This time it can't be equal to 0 because it's on the bottom. So x has to be greater than 0. The reason why this changed, in this example, the square root is on the top. You can have a 0 on the top. But in this example, the square root is on the bottom, so it cannot equal 0. It just has to be greater than 0. Because if it's 0, then the bottom would be a 0. If it's less than 0, then this thing ends up being imaginary. So again, we still have the 2 domain restrictions because we have a fraction and we have a radical, but I cannot say greater than or equal to because the radical's on the bottom. Okay, it's just a couple little tricks to make sure that we look at. Next one, let's find the product of g and h. G, negative 4x plus 1 times h, 1 over x plus 2. Again, because this is a fraction, you have to remember fractions is top times top, bottom times bottom. This was not a fraction, so I can always put a 1 underneath. Whenever you multiply something by 1, you have that multiplicative identity property. Remember, you multiply by a 1 and it doesn't change anything. So if I take negative 4x plus 1 and I multiply by 1, I get negative 4x plus 1. On the bottom, if I take x plus 2 and I multiply it by 1, I get x plus 2. Boom! Your domain. You can never have a 0 on the bottom, so x cannot be a negative 2 because negative 2 plus 2 is 0. Okay, now there is a number here. So we have to go ahead and replace all of the x's with negative 1. On the top, you multiply before you add. Negative 4 times negative 1. Negative times a negative is a positive. 4 times 1 is 4. 4 plus 1 is 5. On the bottom, negative 1 plus 2 is 1. 5 over 1 is 5. Last question. Take g of x, negative 4x plus 1, over m of x, square root of x. Guys, remember? Well, okay, we're going to go ahead and do this. Let's just say you kept it like this, okay? Then we will talk about rationalizing the denominator. Okay, so if I keep it like this, x would have to be greater than 0. It can't be negative because it would be imaginary, and it can't be a 0 because it's on the bottom. However, remember you're never allowed to use or to leave a square root on the bottom of a fraction. So what you would have to do here is multiply both top and bottom by the square root of x. This is called rationalizing the denominator. So now your top would have a square root of x, and you would still have the group negative 4x plus 1. The bottom, the square root of x times the square root of x, is the square root of x squared. The square cancels the square root, leaving this just an x. In this format, your domain is x can never equal 0, and x has to be greater than or equal to 0. The reason why this one gets to include it is because it's on the top. If you understand to here, feel pretty good. If you get it to here, that's better because this is where we're going, okay? If you have it to here, you're getting the operations. Don't worry about it, I'd count this right. The sooner you could do this, the easier the upcoming topics are going to be. Today's assignment is just a worksheet. Again, what you're doing is you're going to go ahead and add, subtract, multiply, and divide. So you're finding the sum, the difference, the product, and the quotient of two functions, and then you will go ahead and state the domain of the new function. Hope you guys had a great day, and I'll talk to you soon.